Hello, my name is Daniel Noble, and this is my presentation for Astronomy 101. How does galaxy formation and evolution expand our understanding of the universe? As most of us know, an event 13 billion years ago occurred called the Big Bang. It was a massive explosion that sent new gases, dust, stars, and dark matter all throughout the newly created universe at high speeds. These gases would form massive clouds that were light years in height, and there was dust and debris fields that turned into asteroids and eventually planets. These dust, gases, and stars, though, started molding together over the course of millions and billions of years, forming today what we would call galaxies. Now, of these galaxies, there are three distinct shapes, or basic shapes: spiral, irregular, and elliptical. From these three basic shapes, we have offshoots. So spirals can have a bar feature in the center, called barred spiral, and have loose or tight arms, like this one. Irregular galaxies can turn into peculiar galaxies, or these can be their own thing, depending on how they form or interact or merge with other galaxies. And elliptical, the biggest, can evolve into lenticular galaxies, which are the same thing, but they're more disc and flat shaped throughout their life. So how do they form in the first place? Well, science technically doesn't have an answer to that, or at least a definite one. It is a difficult undertaking with modern science to recreate the events of a galaxy's formation accurately. But there are two main theories as to how it could have been, or two main theories that are at least discussed, which is the first theory is that gravity was behind the formation of galaxies, which it technically is. This theory, though, focuses on gravity pulling gases and debris together to form stars. These stars would clump together, forming clusters, and these clusters would then join together to form galaxy shapes. However, this theory does get a few things wrong, or at least doesn't talk about it, which is where does the black holes in most galaxy centers come from? Where does the gas that makes up most galaxies and forms new stars go, or how does that appear? And other basic components of galaxies. Again, it's still a logical theory, it's just there's missing a few things. Second theory in this video I'll show is that smaller, lesser galaxy clouds that haven't formed yet zoom through space and combine with other protogalaxies. That's what they're called. Gravity brings these clouds together, having them expand out and start to form shapes that we saw earlier. So again, we have what appears to be a bar galaxy maybe forming. We have spiral galaxies, and again, this is over the course of millions and billions of years. At the very end, you can end up with something called like an elliptical galaxy with a shape like that. So how do shapes and evolutions differ? Well, again, from the Big Bang, we have the building blocks. These building blocks start forming clouds and start forming shapes of protogalaxies. Protogalaxies start forming spherical shapes, and then from that it differs. So if a group of protogalaxies in isolation form together, they usually turn out into more spiral galaxies, which again can lead to bar galaxies. And if something happens along the way that screws up the formation, you can get irregular or peculiar galaxies. Otherwise, you have protogalaxies that continuously merge, forming protogalaxies, or not protogalaxies, elliptical, which are again the gases in these galaxies or these protogalaxies burn out far quicker, forming stars. These stars burn out a lot quicker, and you have massive cloud galaxies formed mostly of red stars. So again, this is where elliptical and lenticular galaxies come from. You also have, so again, galaxies also give us a great lesson of how the universe has developed and where it's headed. So again, elliptical galaxies are the oldest in the universe, almost as old as the universe itself. And they can be made up of trillions of stars and be over millions of light years in diameter. Whereas spiral galaxies are the newer galaxies, which ones we can see, and they're only billions of years old, but still, or lesser billion years, still considered young. They're only hundreds of billions of stars and only 500,000 light years across. They allow us to form a greater understanding of how the Big Bang occurred, where it potentially occurred, and where the future of our universe is headed. It's like using a time machine in reverse. So by studying and understanding the formation, interactions, and evolutions of galaxies, it has given us a monumental understanding of the universe, our place in it, and what may lie beyond its borders. And that is always worth more time, commitment, and study. Here are my sources. Thank you.